Hello, in this video we're going to do a general equilibrium problem where we have a two-consumer, two-good, two-firm economy. So consumer A, its utility function is over good X and good Y. Consumer B's utility function, again, is a function of good X and good Y. There are two firms. Firm X produces good X, let's say, using capital inputs and labor inputs. And firm Y produces good Y using capital inputs and labor inputs. The initial endowments, consumer A has 800 units of capital and 100 units of labor, and consumer B, 400 units of capital and 200 units of labor. So let's start by solving consumer A's demand equations. So we'll get a couple marginal utilities here, the marginal utility of X and the marginal utility of Y. I'll form the marginal rate of substitution, which is the marginal utility of good X divided by the marginal utility of good Y. After simplifying that, the marginal rate of substitution simplifies down to this. We'll set the marginal rate of substitution equal to the ratio of the price of good X to the price of good Y. In order to maximize utility, this condition must hold. So the marginal rate of substitution, as we just solved, is this on the left-hand side. Solving this equation here for Y, we're going to now plug it into consumer A's budget constraint. Consumer A's budget constraint, I represents income of consumer A. And then we got the usual price times quantities here for good X and good Y. So making a substitution for Y subscript A, we get the following. And we're going to solve for X. Simplifying price of good Y's cancel here. Rewriting that, adding up the right-hand side, and getting the demand for good X. So consumer A's demand for good X. To get consumer A's demand for good Y, we're just going to take this demand for good X and plug it into our Y subscript A equation that we saw on the last slide. We could also plug it into the budget constraint either way. So nevertheless, plugging it into our Y subscript A equation from the last slide. Get this result. So where I have X subscript A, I'm plugging in this term here. You can see it right here. And simplifying, we have consumer A's demand for good Y. Same thing now, but from consumer B's perspective, we're going to solve consumer B's demand equations, getting the marginal utility of good X, marginal utility of good Y, forming the marginal rate of substitution, which is the marginal utility of good X divided by the marginal utility of good Y, setting that equal to the ratio of prices to maximize utility, making our substitution here, solving for Y subscript B, and plugging it in now into consumer B's budget constraint. I is consumer B's income, so making that substitution here and solving for X subscript B. Moving on to the next slide. Adding up the right-hand side and solving for X subscript B. Consumer B's demand for good X is given as follows. We'll plug this equation, this demand equation, into consumer B's YB equation from the last slide to get the demand for good Y. So making the substitution here, X subscript B is I subscript B multiplied by 1.5 times the price of good X, making that substitution. Doing some simplifications, notice the price of good X will cancel with the price of good X down here. We got consumer B's demand for good Y. Moving on. Our next step is to form the market demand for good X. So we're just going to add consumer A's demand plus consumer B's demand for good X. So making our substitutions then. We have the market demand for good X. We could get the market inverse demand by solving this for the price of good X if we wanted to, leaving us with this result. So the inverse market demand and the market demand for good X. Doing a similar thing for the market demand for good Y, adding up consumer A and consumer B's demand for good Y. So market demand for good Y is just Y here. So here's the market demand for good Y. If we want to get the inverse market demand, we'll solve for P subscript Y to get this result. Okay, moving on. We'll go to the production side or the firm side now of the market. We have firm X here, produces good X, units of good X. We want to derive the input demands for good X. So getting the marginal product of labor and the marginal product of capital, taking those partial derivatives of this production function. We're going to form the marginal rate of technical substitution, which is the marginal product of labor divided by the marginal product of capital. So dividing the marginal product of labor divided by the marginal product of capital, and simplifying leaves us with this result. Setting the marginal rate of technical substitution equal to the wage divided by the price of capital. W is the wage, R is the price of capital. So the left-hand side, as we just saw, is K divided by L. Solving for K, and now plugging that result into the production function up here. We get this result, and we want to solve this for L. Solving this for L will be our input demand for labor. So rewriting that last step from the last slide. Doing some simplification here. Square root of L times the square root of L is just L. And now solving for L. So we have the demand for labor. This X here, there's a little bit of a gap here, but this X is being multiplied by this stuff right here. So let's take this labor demand and plug it back into the production function. Okay, here's our production function. So plugging this labor demand back into it, we'll now get the input demand for capital. So simplifying this, you get this result. Dividing through by x to the 1/2, left-hand side becomes x to the 1/2 power. Moving some things around here, multiplying through by w divided by r, all raised to the 1/4 gives us this. And we'll square both sides now. And we have the input demand for capital for firm X. We'll do the same thing now, but for firm Y, we're going to drive the input demands for labor and capital for good Y. So proceeding in a similar manner, here's the marginal product of labor. Here's the marginal product of capital, forming the marginal rate of technical substitution, which is the marginal product of labor divided by the marginal product of capital, simplifies to K over L. We're going to set K over L equal to the ratio of the input prices, W divided by R. Solving for K and plugging into the production function, we'll get the input demand for labor for good Y. Okay, simplifying here. Get this result. We're going to take this labor demand and plug it back in the production function to get the capital demand, input demand for capital. So taking L subscript Y, plugging it in here, Leaves us with this result, and now just a matter of simplifying this mess. We'll simplify down to the following. So that is our demand for capital. So let's derive the market input demand for labor by taking the labor demand for good X and the labor demand for good Y, and then just adding them up. We get this result. And we'll do a similar thing. We'll derive the market input demand for capital, adding up the input demand for capital for good X and good Y. We get this result. Okay, moving on. We want to derive the supply equation for good X. So first note that in general, total cost is just the wage times units of labor plus the price of capital times units of capital. And we have the input demand for labor and input demand for capital solved earlier. And now I'm just going to substitute these input demands into the total cost function. So here's after our substitution, we get this result. To get, now what we want to do is get marginal cost. Okay, the marginal cost represents the supply equation in competitive markets. So I did it. Well, we can do a little simplification here. So this will simplify to the following. This W divided by W to the 1/2 is just W to the 1/2 in the numerator. And the same thing here. It'll leave us with R to the 1/2 in the numerator. So now getting marginal cost by taking a partial derivative with respect to good X. Noting in perfect competition or competitive market, price equals marginal cost. Oops, sorry. We can write the following result. Doing the same thing for... All right, we're going to do the same thing, but this time for good Y. We're going to derive the supply equation for good Y. Total cost of producing good Y is given like this. As before, we're going to take our input demands for good Y for labor and capital and plug it into the total cost equation, giving us this result. We're going to simplify this mess, and we get the total cost of good Y equaling the following. To get marginal cost, we take the partial derivative of total cost with respect to good Y. And then this is the Y just drops out here. And recognizing once again in perfect competition, price equals marginal cost, we have our supply equation for good Y. Okay, moving on. So let's summarize what we have so far. So for good X, we have a supply of good X and the demand for good X. For good Y, we found the supply of good Y and we found the demand for good Y. And for labor, the supply based on the initial endowments of labor at the very beginning was 300. And our input demands, our market input demand for labor, we solved as follows. As for capital, the supply based on our initial endowments by adding up the initial endowment of consumer A and consumer B's initial endowments of capital is 1,200. And then we derive the market input demand for capital as follows. Okay, next step. We're going to normalize the price of capital to equal 1, so R equals 1. We could have normalized any of the prices. I just picked one. We cannot uniquely identify any market price, so we can implicitly identify them by normalizing one of the prices to 1. So let's start with the labor market equilibrium. And labor market equilibrium, we're going to just set the supply equation equal to the demand equation. And we're going to make our substitution by letting r equal 1. Okay, so there's an r, it's now 1. I'm going to solve this for x. Okay, so just simplifying here, moving some things around. And we get the following: x equals this mess. And what I want to do now, I want to plug this into the equation below. And that's going to be our capital market equilibrium, where we set the supply equal to the demand. And here I already normalized r equals 1. Okay, so that's why we're not seeing r in there anymore. So where I have an x, I'm plugging in this 300w to the 1/2 minus y divided by 4. And we're going to solve this for w. And some nice things cancel here. These y terms will eventually cancel. And so we get a wage of 4. Moving on. All right, right now we're going to solve for the price of good x. We're going to take the supply equation for good x, and we're going to substitute in the wage we just found, which is 4. And remember, we normalize the price of capital equal 1. So making that substitution, we get 2 times 2, which is going to be 4. So the price of good x is $4 per unit. And we're going to now solve for the price of good y. Taking the supply equation and putting in our w and r. The price of good y is 1. So with those prices, we can evaluate consumer A's demand for good x. Here's consumer A's demand. What we will need to get is consumer A's income. What is consumer A's income? It's going to be the wage times consumer A's initial endowment of labor plus the price of capital times consumer A's initial endowment of capital. So this L and K, that's coming from our beginning slide. And we said A had 100 units of labor and 800 units of capital. So when we multiply those numbers by the respective prices and add them up, consumer A has income of $1,200. So going back to our demand for good x for consumer A and plugging in our values for now income and the price of good x, we get 1,200 divided by 12, or 100 units. So consumer A will get 100 units of good x. And let's also consider consumer A's demand for good y. Here's consumer A's demand for good y that we solved earlier. Plugging in consumer A's income down here, 1,200, and 3 times the price of good y, where the price of good y is 1. Consumer A will consume 800 units of good y. Consumer B's demand for good x. Here's consumer B's demand. We need to get consumer B's income. So similar to what we did with consumer A, we evaluate the initial endowment of consumer B at the prices that we solved for. W is 4, R is 1. Consumer B has $1,200 of income. So $1,200 of income, price of good x, as we found in the last slide, was 4. Consumer B will consume 200 units of good x. And as for good y, consumer B will consume 400 units of good y. The total number of units consumed by consumer A and consumer B, 100 and 200, or 300 units. And the total units of consumed at good y is 1,200 units. So kind of summarizing what we found earlier, 800 and 400. All right, let's take these input demands for labor and evaluate each one at our values that we've been solving for. R is 1, W is 4, and X here is 300 right up here. So input demand for good X. Labor input demand for good X is 150. Labor demand input for good Y will be 150. Okay, simplifying this, 1/2 and then 1200 divided by 8, so yeah, it'll be 150. And here is the capital input demands for good X and good Y, evaluating those at our wage and price of capital and values for X and Y. Capital input demand for good X is 600, and capital input demand for good Y is also 600. And that is it. I hope you found this video helpful.